Welcome to the Ultralight Airplane Workshop. My name is Leon. Let's make a carbon fiber sample using the Resin Infusion method. On our last carbon fiber sample video, we used the wet layup method to make our sample. This time we're going to use Resin Infusion, where we use a vacuum to draw the resin into the part and through the part. I haven't done Resin Infusion before, so this may end up being a video of what not to do. But regardless, we're going to have a lot of fun. We're going to make quite a few changes over the last video in making this carbon fiber sample. Now, I've already mentioned we're going to use Resin Infusion. We're also going to change what we're using for the flat surface, and we're going to change how we cut out the carbon fiber. I went to Home Depot and got some whiteboard, a 2-foot by 4-foot piece of whiteboard that I believe is intended to be used for dry erase marker. I assume that the surface of this board has been prepared to allow the dry erase marker to work on it, which is probably something very similar to the release coat we're going to use, which is another thing that's going to change in this layup. Now, this whiteboard has a nice flat surface. It's not porous. And it should give us a much better finish than we had on the previous layout, where I used a piece of cheap furniture door, which was a flat piece of MDF with a thin plastic coating on it, but that coating had a texture. I sanded down that texture to try to make it a little bit smoother. I didn't realize that in the process I had made slight pinholes in that surface. So when I put the wax on it, the wax seeped down in those pinholes, and over time caused that MDF to swell up into little pimples. So I didn't get a very smooth surface on that piece of carbon fiber sample. What I'm going to be using for the release agent is different than last time also. Last time we used wax with 3 coats of PVA, polyvinyl alcohol, on top of it. This time we're going to be using Loctite 700 NC Free Coat. This appears to be a fairly common release agent, so we're going to give it a try. I'm applying this free coat in 3 coatings using a different wiping orientation for each coat. So on the first coat, I'm going left to right, wiping it down. On the second coat, I went fore and aft, away and then back toward me, back and forth. And then on a third coat, I went at a 45-degree angle. The reason for going these different directions is that I'm less likely to miss a spot. I'm probably going to get at least 1 coating on everything, more likely 2 coatings, even if I miss a couple of small spots. For allowing each coat to dry, I stayed around until I saw that there was no more visible moisture on the surface, and then I allowed it to dry another 30 minutes after that. I wanted to give it what I had hoped was sufficient time to dry so that when I put on the next coat, it wasn't dissolving the previous coat. And I did have that happen with PVA when I didn't let it dry long enough. So this board looks pretty good. Let's proceed on to the carbon fiber cutting. Another thing we're going to change during this layup is the way we're cutting our carbon fiber. Last time we cut it, I was pretty unhappy with the way these toes kept unraveling and sticking out. Now, I mentioned in the last video, I thought it was interesting that when they shipped the carbon fiber to me, they had applied a little bit of tape to the edge to keep it from unraveling. And then I just kind of ignored it. So for this time, we're going to put some of our own tape on there. I've already applied tape and cut out our first layer of carbon fiber. We're going to have 2 layers. So I cut it from this part of the carbon fiber. I laid down a piece of tape, 3/4 inch masking tape, along one edge and then 3/4 down along another edge. I left the original edge that came with the carbon fiber. I did not do one of the edges. The reason for that is I'm not sure when the resin is flowing through this carbon fiber if the adhesive on the tape is going to dissolve and then also flow into the carbon fiber and cause some issues with my epoxy not curing properly or being weaker. So what I'm going to do is I'm going to have the epoxy flow in from this rough edge. One of the experiments I want to do before long is try the resin by itself and the hardener by itself on little dabs on the tape and figure out if it dissolves the adhesive on the tape. If it does not dissolve the adhesive, I'll go ahead and do all 4 edges in the future. Now, of course, this will not work if we're doing layers in a large part where we have to have seams. Can't have this tape be in the middle of a seam between 2 pieces. So in that case, we're just going to have to live with the toes coming apart a little bit. But out on the edges, which are going to be trimmed off, I think it'll be okay to put the masking tape to keep that from unraveling. I want to mention on this carbon fiber, this is really just for doing some testing on the processes for dealing with epoxy and for curing. This is a twill that is not of airplane quality. Number 1, it's seconds, which means it has imperfections in it. Number 2, it doesn't have the correct stiffness. It's not stiff enough for what we're going to use. It's very flexible, at least as far as carbon fiber goes. But it does have roughly the thickness that we expect per ply, or at least that we're anticipating. The major difference is that these toes are fairly narrow. I'm going with wide toes on the airplane. So that's one significant difference. But we'll have to do a little testing on the intended fabric at some point in the future. So let's cut out our other layer for the carbon fiber. Next, I'm going to cut the peel ply. The peel ply goes directly on top the carbon fiber. The purpose of the peel ply is to keep the layers that go on top the peel ply from sticking to the carbon fiber or to sticking to our mold. I'm going to cut this peel ply just a little bit oversized, or at least a little bit larger than my carbon fiber is, but not much, just marginally larger. If we were doing a curved piece, I'd cut it quite a bit larger so that we could put pleats into the carbon fiber on those curves, or to make cuts in it to make it fit curves. Might be useful to mention quickly how peel ply works. This is a Dacron cloth. Epoxy and other resins don't stick to it very well. In addition, it has a very tight weave. So any epoxy that is on top seeps through and goes underneath, that makes very small connections on there, can be easily broken when we go to peel it off. Those are very, very tiny epoxy connections. They're brittle and fragile and can be easily broken as we pull on the peel ply. Another reason for peel ply is that if we wanted to use adhesive to glue something to our carbon fiber, let's say another piece of carbon fiber, this peel ply, after we peel it off, will leave a rough surface that makes it easier for adhesive to make a good mechanical bond between our 2 pieces. The next layer in our stack of layers for this resin infusion test is called the infusion mesh. This is plastic that has very large openings in it, and it's somewhat thick. No, not real thick. One of the purposes of this mesh is to allow resin to flow over our part, getting resin easily to the various parts of our part as it's flowing. And it also easily allows air to come up as the vacuum is being pulled and to be pulled out. I'm going to cut this piece about the same width as our part, but a little bit longer. There's going to be a port that we put where resin comes into the part and a port where we want resin to come out of the part. Now typically when we were using a mold, we would actually run our piece of carbon fiber out a little bit further, and the resin would come in and spread out and come down and then come back in again. I'm not going to use that much carbon fiber. What I'll do is I'll just use more mesh to help feed it out and then back in. I also want a few more pieces. Well, you'll see here before too long there's going to be some spiral tubing that we put in here. So I'm going to put a piece of mesh over the top of that, help the resin flow out of that tubing. And I'm going to put a little bit more mesh down here where we're going to pull the suction so that resin and air will have a little bit easier path to get out. One of the drawbacks of this mesh though, and it's the major drawback for resin infusion, is that after we get our resin pulled in, all these openings are going to be full of resin, which means it's resin that's not going into our part. It's going to be waste resin. That's one of the things I don't like about resin infusion is there's a tremendous amount of waste as far as your resin goes. This blue sheet is the top layer of our layer stack. This is bagging material. This, combined with our mold, will be used to hold the vacuum. This particular sheet, I believe, is the non-stretchy variety. I've purchased a stretchy variety and a non-stretchy variety, but the supplier did not put a sticker on it, so I'm not positive which version it is, but I do believe it is the non-stretchy variety. I'm going to cut this one quite a bit bigger. We have to come outside of our other layers to put down what's called a butyl tape, sticky tape, and our bag has to at least stretch out to where that tape is going to be on the mold. In addition, we're going to have an input port and an output port, resin in, air and resin out, and that's going to bunch up. And since this isn't stretchy, I need to give a little more material in there so I won't have large voids that our resin will try to fill. So I'm going to make it a little bit bigger, and we'll put some pleats around the edges to take care of that. I'm going to use my other scissors I'm using for materials that are not ever going to come in contact with resin. This outside edge will never be in contact with resin, so I really don't care what kind of scissors I use for it. Okay, well, that is our top layer. Next thing to do is start preparing to put our layers together. Well, now it's time to put the seal around our part. This mesh is the biggest thing we're going to have, so that tells me how far out I need to put the tape. What we'll be using is this butyl tape or sticky tape. You may not be able to focus on that. There we go. We'll put this all along the outside edge where we want to seal our top layer down. We want to make sure we don't have any leaks, so corners, I'm just going to turn this around instead of tearing off a piece of tape. Make this one continuous piece of tape around here. Now, this stuff isn't very expensive, but I've been told that you can also use butyl tape from places like Home Depot that use it for window installations. I haven't tried it yet. That'll be an interesting experiment for the future. But I got this tape the same place I got all my other materials for doing composites. This stuff's easy to tear. Well, semi-easy to tear. Should use some scissors on that. All right. All right, that should make it so that we can get a reasonably good seal around there. Let's press it all the way down. You know, I have a roller for this. I bought a roller to aid me in this. Now I'm going to leave this top tape on here so that I won't accidentally be getting my layers stuck to it as I start putting them in here. And then just before I put the top layer, the bagging layer on, I will take this white tape off. All right, there we go. Now we're ready to start laying in our layers. During this next segment, I had failed to realize that my workbench camera had completely failed to focus. So mostly you'll be looking at a talking head, but with a few shots of the bench out of focus so you can at least get an idea of what the talking head is trying to talk about. It's time to start putting our layers down. So I'm going to put down my carbon fiber layers. The side that does not have tape along the edge, I'm going to put over here on this, my right side, your left side. So the epoxy will flow in from this direction. Now to keep these from moving around, I'm going to put a little masking tape down. Now I have seen other demonstrations where masking tape is used to hold down various layers. Now they didn't use a whole lot, so it must not be too bad to use. I'm trying to get these fibers fairly straight so that when we do our testing, we'll get our best performance out of our piece. Okay, here comes our second layer of carbon fiber. If I convince myself that the masking tape is not an issue with the resin, I'll put the tape on all four edges. Now it's possible that will cause a little bit of an issue with the flow of the epoxy. I do not know. It's one of the experiments we'll have to try. Now we put down our peel ply. I'll use a little bit of tape to hold that down. Next is the resin mesh. Okay, that will go on top our spiral. We'll put this down here to give it a little additional flow area. Next thing I'm going to do is work on the infusion side where the resin comes in to our layer. Well, I've got here some spiral tubing. What we'll do, stretch this out just a little bit, we'll lay this tubing over here on the input side. Resin will come in and flow down through the tubing and across the part. At least that's the idea. Well, we have to get resin through our top layer and into the spiral tubing. Now typically you would use something like this input port, except the port would have some grooves in it to lay on top of the tubing. This is not the input port that I really want to use for this. If I get resin in this, it's pretty much going to ruin it. So this is really intended for bagging a wet layup where there's little to no chance that you'll get resin where you're pulling a vacuum with this. Now, unfortunately, I did not get the kind of silicone port to put over this, but I do have these T's. So what I'm going to do is stick a T here in the middle of this. So now I've got this T stuck in it. What we'll do is tape this down. Then when I put the vacuum bag layer on, we'll poke a hole in it, and then we'll use our tape to make a seal around that hole. Well, my camera ran out of juice during the middle of the last shoot, so I will go over again what I did for you. We got the input side where resin comes in, the output side where we pull vacuum, and some resin may come out. What we want is to draw the fusion through that spiral tubing. And the resin will come out between the spaces. It will come out in the spaces in the spiral. We want to put resin mesh on top. If we had only put the bag on top, the bag would end up sealing maybe half, maybe a little more than half, so resin could not get out. It could only go down through the bottom. With the mesh on top, resin can come out all the way around and run down and come out. I did something similar here down on this end where we're going to pull the vacuum. Now down here, I'm not as interested in having resin come out through here. I want air to come out through here. Since I didn't have a port, again, I used one of these T's, and I'd put just a short piece of tubing in here and then mesh on top. So air will be able to flow down through here and into this little port that I've made up. Well, the next thing to do is put on our bag. Now I want the bag to seal around this. The ports that come with it have nice flat areas that you can seal against, but we don't have that in this case. So what we're going to do is try to use a little butyl tape for that. So I'm going to try to figure out how long a piece to cut. What we'll be able to do is mash our bagging film down into that and make a seal. So I'm squishing it down in there to try to get a good seal between the tube and our sticky tape. Well, I don't know how much of that last little bit got recorded putting the vacuum bag on. I started with the ports here. I think I explained the rationale for these ports instead of nice silicone ports. I first put butyl tape around them and squished it down, tried to seal it around the tube. Did that both on the input side and the output side. If you'll remember, I had left the tape on top, the outer edge, so nothing would stick to it while I'm working my way around sticking down the tape. What I did then is I put a small hole in my vacuum bag, put it over there, and then squished it down in here as best I could, trying to make sure I'm not going to get any leaks. Now, it's not going to be perfect, but I think it's done pretty well. I did this on both sides. I wanted to put pleats where these ports are, both on the ends and on the sides, because this is not a flexible or stretchable bag, so I don't want to take any chances that it's going to rip. I want to have plenty of excess bag in here so it can move around and won't stretch hard and cause issues. I started by putting a little 1-inch pleat down here. I cut the protective tape off, peeled it back just a little ways, cut another piece of tape off, stuck it in here, and then wrapped it down, and then begin working my way around, making sure I don't have any creases as I push it down into the butyl tape. I pull it out smooth and then press it down. Once you press it down, it's hard to get off. Now, if it just barely touches, you can peel it back off, but once you press it down, it's in there pretty good. Then I did another pleat down here, just like I did this one, so I have a little excess bag. Work my way around, putting in a pleat, trying to make sure I don't get any wrinkles in here, pressing the bag down as I go, and I work my way around to the end. The end one was the hardest one to do, and I'm going to have to go back and review some YouTube films and figure out a little bit easier way to do it, because I just kind of stumbled my way through it. Now is a good point to stop and talk about a couple of mistakes that I made. One was a significant mistake. The second one wouldn't have been a mistake if I hadn't made the first mistake. The first mistake, which was the biggest mistake, is that on the input port, when I was attaching the vacuum bag to the sticky tape around the T connection, I got a very slight wrinkle, a very slight crease in the vacuum bag. Later in the video, when I put the sticky tape on top of the bag around the T connector, that wrinkle is still going to be there and still going to allow air to go through that wrinkle in the vacuum bag. In vacuum bagging a wet layup, this would not have been a problem. It was a very small leak, and the vacuum pump was able to maintain the pressure of 24 inches of mercury. So it would have been able to keep plenty of pressure on the part and squeeze out excess resin. But with vacuum infusion, in that particular spot, it was a very serious problem. If I hadn't made the second mistake, I would have been able to find that leak and fix it. The second mistake, as you'll see in this diagram, in the outlined red area, there's no carbon fiber there underneath the mesh. The issue was I could not see air bubbles traveling through the mesh there. Air bubbles were basically the same color as the background, which is white. If I extended the carbon fiber back underneath that input port and under the mesh and the spiral tubing that mesh is setting on, I would have been able to see those bubbles going through, and I would have been able to figure out what the problem was and then possibly fixed it. I have myself a nice fancy cup holder here. This cup may not hold enough resin to completely infuse this part. So what I'll do is I'll get started with the first cup. If it looks like it's going to get down close to the bottom of the cup before I'm completely infused, I'll just stop it, keep the vacuum going, but clamp the hose shut, and I'll mix up another one and pour it in. 2 should be plenty to do this part. So let's cut our hose. I got some hose here that we can use. This is kind of stiff. I kind of wish, at least on the input side, I had a more flexible hose. Now again, this is one place where we're going to waste some resin, because we're going to end up leaving resin in the hose because we don't want to pull air in. One of the tricks I learned at Oshkosh this year is you don't want to cut your tubing straight across. You want to cut it at an angle. The reason for that is that if you cut it flat, your tube may make contact with the bottom of your cup and seal. Make a tight seal and you won't get your resin in any longer. Actually, I cut it at 2 angles. I cut it flat and at an angle about halfway across. Just stick this down on here. Okay, what I'm going to do after I get my resin mixed is I'm going to use a clamp to hold this tube to my cup. Now I can tell that it's going to be a little bit difficult. This is really stiff tubing. All right, that'll work. Now, I have just a little bit more sealing to work on. I want to put some more sealant, some more butyl tape around here to try to ensure I'm going to get a seal there. So I'm going to press it up against the tube, tight, and down against my vacuum bag. All right, I think that'll work. So on this end then, I need to run over to my catch pot. One of the tricks I also learned at Oshkosh for your catch pot is if you get epoxy into the catch pot and you haven't done anything about preparing it, the epoxy is going to stick in there and you don't want that to happen. So one of the things I learned is you take your release agent, whatever you're using, we're using Free Coat, and you wipe the inside of your catch pot with the release agent. That way it's easy to peel the epoxy off if any gets in there. So that's what we're going to do next. So we will put it that direction. All right, now let's put some more butyl tape on this. Okay. Oh, hopefully that comes close to making a nice seal. Next thing to do is to check the vacuum. See if we got a good seal all the way around here. So the way we're going to do that is with this handy dandy little clamp. I talked about this in the unboxing video. What we'll do is we'll put this clamp on the hose on the input side, and we'll screw it down, and it'll compress the hose or the tubing in a small spot. And seal it shut. That way we can pull a test vacuum. It'll let us pull a test vacuum, number one. Number two, when we get all the resin infused that we want, we have to seal it off again so that we don't end up pulling air into the part. We now have that sealed off. Okay. So our pot's ready to go. Well, I've set up the hoses to do the vacuum. We got the hose going to the resin bucket, or in this case, cup. It is not yet closed off. I've got it unclamped. Don't know if you can quite see that here, but it's not clamped up yet, so it's open. I have the hose for the exit part, where we're going to draw the vacuum, going into our resin trap to trap any resin that might make it up into this tube. From the resin trap, we're pulling a line over to the vacuum pump. So we have some redundant gauges here. We have one vacuum gauge here on the trap, and we have another vacuum gauge on the pump. Now I've already pulled vacuum on this once just to test to make sure it would work okay. I did have one air leak that I could locate. There was an air leak over here on the input port. I could hear it, a very soft hissing sound. I could hear it over the noise of the pump. So that worked out pretty good. All I had to do was squish down on the sticky tape, and then it sealed it up, and I no longer had that leak. I can't find any other leaks. Now there is very slow leak in the system, but I don't think it's going to be an issue unless I can see the air bubbles coming into the resin as we're pulling it through. If that is the case, then we'll definitely have to work on that leak. So let's test and see how much vacuum we can get without our bag in the system. So I've got a valve here on the trap that's shut off. So when I turn on power on the pump, all we're doing is pulling a vacuum on this line, and that's as far as it goes. So let's get that going. Well, it's already pulled 24 inches of vacuum, and that's the same as I got when I did the test before. So let's turn it off and see how slow it leaks out. So we've got a little bit of a leak here in either through the diaphragm of the pump or here in the hoses, or possibly in our valve. So I'm just going to probably have to live with that. One thing I learned about this pump is if it has a vacuum on it, you can't start it again after you've stopped it. You have to release the vacuum and start again. Now, let's open the valve and let's pull a vacuum on the whole system. Now the reason we're not pulling a vacuum yet is I haven't clamped off the input hose. So put the clamp on this hose. There we go, we're pulling a vacuum. Aha, so we got a little bit more leak. Oh, no, looks like we're making it. Not quite there. I think that's going to be good enough to go ahead and pull a vacuum to pull the resin through. Part 1 of this video is getting a little bit too long, so we'll stop it right here. In part 2, we'll find out what the symptoms of my earlier mistakes were, and we'll find out how well the part turned out. And as a little teaser, it turned out better than I expected it to. Part 2 should be out in a couple days.